All right, we are live now. So I would like to welcome everybody to the third NUTRI-KNOW webinar about application, or specifically fertilizer application. My name is Daniel. I'm from the European Science Communication based in Germany, or short ESCI, and I'm the communication manager of the NUTRI-KNOW project. I have the pleasure of hosting this webinar, which means I will oversee all the technical stuff, and I will also monitor the chat and the Q&A functionality we have here. So feel free to ask your questions using either the chat or the Q&A tool. I will have a look at them, and I will then ask our speakers at an appropriate time when they are ready for the question. That being said, so today we have a lot of content, around 50 minutes of input, and then we have 10 more minutes for questions. But we have a community of practice implemented within the NUTRI-KNOW project. Feel free to explore it and to sign up. It's very easy to use. And there you have the possibility to ask your questions regardless of any time there is left in the webinar or whatever. And then we have our experts and other farmers and practitioners that can answer them. So it's really a space for dialogue and exchanging ideas. So feel free to give it a try. And with that, I give it over to Hong Zhen.
Thank you, Daniel. This is Hong Zhen from Ghent University in Belgium. I will introduce the webinar, the main content of the webinar and application. So as you may know, in NUTRI-KNOW project, we have the value chain divided in 6 steps. And here we have the application step. That's the last step, but it's a very important step to maintain a sustainable nutrient management. So when we talk about nutrient application at farm level or field level, you probably think about applying fertilizer like the left side manually or with the machine. But nutrient application is more beyond that. So it's also refer to what type of nutrients you are applying, what type of farming system you have, is there any technologies or tools available, and what are the associated management on soil, crop, and water, etc. So it was also highlighted in Farm to Fork strategy that we need to reach some sustainable targets by 2030. For example, we need to reduce 50% of the overuse and risk of chemical pesticides, and also the use of hazardous pesticides.
Ja,
Sorry. And then,
ik denk dat niet, nee. Ik weet niet of ze dat vorige keer gedaan heeft, eerlijk gezegd. Want ze heeft al een IDF meermaals.
Sorry, I think that was not on purpose. I just muted Thomas. Yeah. Go ahead, Hong Zhen.
So the sustainable targets, not only the chemical pesticides, but also nutrient losses. We need to reduce it at least 50% and reduce the use of fertilizers by at least 20%. It's also referred to some antimicrobial, the cells of the antimicrobial for the farms and animals. And there is also a target for achieve at least 25% of the organic farming systems. For this, we have we need to advance our knowledge in application, and a widely known and used is the 4R principle for nutrient application. It refers to right source, right rates, and right time, and as well as right place to apply the fertilizers. This is also our focus in NUTRI-KNOW project, that we try to engage the operational groups that focus on different management of nutrients. Here in this webinar, we will highlight 7 operational groups and involving two manure management tools to reduce application cost and increase precision fertilization efficiency, two technologies to recover nutrients from manure, and three management strategies to integrate the fertilization, crop, soil, and water practices. So here I will hand the floor to Victor, introducing firstly the slurry concentrator.
Hello, everyone. Thank you, Hongzhen. Can you hear me?
Yeah.
All right. Thank you, Hongzhen. Daniel, hello, everyone, and good morning. I'm Victor. I'm from Beta Tech Center. And in this session, I'll be briefly explaining the slurry concentration operational group. This operational group has been developed in the Catalan region in the northeast of Spain. So just following what Hongzhen mentioned, this operational group faces the challenge of manure management. And this is a significant challenge for farmers, particularly those operating in small to medium-sized farms. The slurry concentration provides solutions to improve the use of manure as a fertilizer and potentially export them to nutrient-poor areas where it's needed. Right? So if we talk about the current solutions, we have solid liquid separators, which address this challenge by producing liquid and solid fractions. However, if, let's say, if this solution was perfect, that's it, no? We don't have to explain anything else, no? But this current solution has some difficulties. Like different machinery is needed for each fraction, and therefore complicates all application, resulting in heavy investment for farmers and difficulty in monitoring nutrient application. So the innovation what we want to present consists of a new concentrator, that separates the manure coming directly from farm into two phases. A first semi-liquid phase containing most of the organic fraction, nutrients and bigger particles, and the second liquid phase with a low nutrient concentration. Current technologies treat manure to produce a liquid fraction and solid fraction. However, for the management and application of the solid fraction, the farmer, let's say, that needs a different type of machinery to load the tractor wagon, transport it to the fields, and then apply the solid fraction to the soil. Then for the liquid fraction, the machinery needed is completely different, consisting mainly of a tractor with a pump, a slurry tank, and a special system for spreading the liquid on the ground to avoid ammonium emissions. This means that the farmer needs to invest heavily in machinery to manage livestock waste. In addition, and I think that it's very important, it's very complicated to monitor the current application of nutrients to the soil, especially the solid fraction. And as a result, soil fertilization is not optimized, leading to nutrient losses and nutrient emissions. The slurry concentration that we want to introduce to you today can be used on any pig or cattle, let's say, slurry producing farm that meets the minimum requirements, size and quantity. So the separator works by being submerged in one of the pits, concentrating the nutrients in that pit and transferring the more diluted fraction to another pit. The main requirement, which may not always be available, is that the two separate pits are needed to store the two liquid fractions produced. This system has the potential to work perfect in other regions as it's not climate dependent, and additionally has the potential to be used on any farm where livestock manure is produced in the form of slurry. It's a system that does not require any support infrastructure and does not require a very high energy input, so farms will already be ready to use it. So with the proposed innovative system, we obtain two liquid fractions, one with high concentration of nutrients, mainly nitrogen and phosphorus, and the other one with low concentration of the same nutrients. The concentrated effluent can therefore be more efficiently transported or applied to any farmland, while the diluted effluent can be used to the surrounding fields. The equipment used to manage the two fractions is then the same, consisting of a tractor with a pump and a slurry tanker, which significantly reduce the investment cost, but also operating costs. as the time required to manage these fractions is also less than with the current solutions. In addition, it's easier to monitor the nutrients applied to the soil, as there is a devices that can monitor the nutrient content on the liquid fraction online, allowing precision fertilization and avoiding nutrient losses and emissions. So what are the results that they obtain with this operational group? There are 3 things that we want to mention today. The first one is that there is an increased efficiency. The innovative system yields 2 liquid fractions, the semi-liquid phase, to be transported and applied to distant fields where nutrients are not available, and the liquid phase, that to be applied in nearby fields. The differentiated management of the 2 phases minimize transport costs and optimize nutrient application to the soil, both from agronomic and environmental point of view. And this is, I think, very important. The second thing is the cost savings. Using the same equipment for both fractions reduce both investment and operating costs, while also decreasing the time required for management. In addition, and I think that this is also very important, the slurry concentration can be a shared solution for a group of farmers or a cooperative. As the proposed separator is a mobile device that can be used in different farms and can be moved. And the third one is the enhanced monitoring and precision. As I already mentioned, the system enables easier monitoring of the applied nutrients to the soil, as online devices can track the nutrient content of the liquid fraction. This facilitates, at the end, the precision fertilization, minimize also the nutrient losses and reduce emissions, and thereby optimize the soil health and its productivity. And the current status of the technology is there was a lot of interest in this innovation. Interest from the livestock sector was really high, and in fact the equipment continued to be tested on different types of farm with different slurry and configurations to demonstrate to farmers that it could improve current management systems. In addition, a new business model was defined in which this equipment could treat an entire slurry pit in a few days, making it possible to consider mobile equipment that could be owned by several farmers. It also provided a better understanding of the various challenges in adapting the current equipment on the farms. As a result, and this is, I think, a key point, as a result of interest shown, the cooperative, that was the lead partner of this operational group, has applied for a patent at national level of this technology. And just to conclude and leave the floor for the next speaker, for any person interested in implementing this technology in your farm, the cooperative of Plana de Vic offers a free simulation of the viability of this slurry concentration technology. Thank you very much, and I leave the floor for the next speaker.
Yeah, good morning. Hi, everyone. I'm Clara Fullano from FECAC, which is the Federation of Agri Cooperatives in Catalonia. And I will explain you the operational group manure management tools, the application part. So this operational group was performed in 2016 by these 6 cooperatives, which produces livestock, cereals, and feed. And they are located in the 2 strong concentrated area of livestock production in Catalonia, which are Lleida and Girona. So the application part of this operational group, the researchers started with the use of conductometers to find out the exact amount of nutrients in the slurry in order to know the amount of slurry to apply in the fields and in the crops. About the application, the second part, they perform different treatments with different fertilizers, mineral fertilizers, compost, manures, all of them applied with 2 systems of applications, which are hoses and brand spreaders. And finally, with the results, they made 4 training sessions in the lands for the farmers to give them advice on how manage this application. So in Plana de Vic, which is the cooperative that has the slurry concentrator that Victor explained to you, they made 2 treatments in 2 different lands. then 10 different treatments in 2 different lands. In the first land, they used the leaky fraction from the slurry concentrator. They first used band spreaders before sowing and buried the manure. And then during the first grow of the crops, they used hoses for the application. And then in the other land, they made 10 different applications, different combinations of the treatments before sowing and treatments with the first grow of the crop to find out which one is the best for these conditions. In AgroCAD, they make 5 different treatments as well. But in all of the lands, they make the first application of a slurry before sowing and buried this manure. These 5 different treatments were always applied during first growth of the crops and were about different doses of the slurry, and one of them was with mineral fertilizer. Then the left for cooperatives has double crop. They sow barley during winter and corn during summer. So they made 4 different treatments of fertilization for each crop, but always used the leaky fraction manure and mineral fertilizers applied with hoses. So for barley, they made 2 applications. First of all, mineral fertilizer and a dose of slurry before sowing. And during the first grow of crop, they make a first lower dose of slurry and then mineral fertilization application. And then for corn, they make 3 applications before sowing. One of lower dose of slurry and another 2 with the highest dose of slurry. And then during the first grow of crop, they make a mineral fertilizer application. So the researchers find out different results for the different lands with the different conditions. And during the training sessions, they could explain these results to the farmers and advise them on how to do the best practices during management and crop growth. But the 4 general conclusions were these 4 points, which were that the best application system is with hoses due to its uniformity, efficiency, and facilities for farmers. Then that the use of conductometers is always needed to know the exact amount of slurry to apply into the crops. That the application of the leaky fraction manure during first grow of crop is always needed to allow the application of nutrients on the right moment of the crop growth. And finally, that it's really important to plan applications and perform the best practices during crops growth. Thank you so much, and I will leave you with the next speaker. We can hear you, Hunsen.
Yes, I'm saying you still need to unmute yourself.
Yes. Sorry. Thank you. Here is Hongzheng again. So I'm talking about more like also livestock intensive region in Flanders. That it's a nitrate vulnerable zone, meaning according to the nitrates directive, that the manure product can only apply to the maximum 170 kilogram nitrogen per hectare per year. So that means in this region there are quite some manure left that cannot be consumed by the croplands in this area. To this end, the Joint Research Center proposed renewal criteria. That means the recovered nitrogen from manure, to promote the use of recovered manure products in the field as a substitution for synthetic fertilizer, meaning they can apply above 170 kilogram nitrogen per hectare per year. And so they propose this renewal criteria based on a meta-analysis of the past research using different manure products. And it means if the products can meet the criterion listed here, then we should be able to use it as for substitutes for synthetic fertilizer. So how we produce renewal products? In this renewal operational group, we use stripping and scrubbing technology. That's the liquid fraction of manure or digestate fits into the system, and the air is blowing the ammonium in a gaseous form from the liquid fraction. And then in the next step, we use sulfuric acid or nitric acid to absorb this ammonium gas and form ammonium salts in either ammonium sulfate or ammonium nitrate. You can see a picture here. That's how it looks like. These are liquid fertilizers, and ammonium nitrate has a nitrogen percentage of 10 to 15%, which is higher than ammonium sulfate, because ammonium sulfate also contains quite some sulfur in the formation. So because these are liquid fertilizers, so we can use a machine to inject the fertilizer into subsoil. In that sense, the ammonium emissions from the application will be reduced, which is more sustainable and also more efficient for the use of the fertilizer. And we, in this operation group, we have 5 field trials conducted to compare it with synthetic fertilizer such as urea and calcium ammonium nitrate. And the result comes that the ammonium nitrate recovered from manure performs equally as the synthetic fertilizers in terms of crop yield and quality. So they are able to be used as a substitute for synthetic fertilizer. However, note that this renewal criteria still need to be taken up by the regulations. So in NUTRI-KNOW project, we have joint feedback on the nitrates directive evaluation by 8th of March this year. So this joint feedback, we highlight the implementation of renewal criterion and the adoption of the legal status of ammonium salts as the alternative fertilizers. So hopefully in the near future, we will be used. These renewal products can be further widely used. Okay, I hand over to the next speaker.
Thanks. On then, I'm Giuseppe Moscatelli from CRPA Research Center on Animal Production, located in Emilia-Romagna region in the north of Italy. One of the main goals of struvite operational group is to decrease the nitrogen and phosphorus content in livestock digestate in order to reduce atmospheric emissions from spreading phase, and also to facilitate the soil application of the phosphorus depleted digestate. To do this, the operational group designed a prototype at farm scale for extracting struvite. Struvite is ammonium magnesium phosphate produced by recovering nitrogen and phosphorus from digestate. During today's webinar, will be briefly report how the prototype treatment is able to reduce ammonia emissions in field application of the treated digestate compared to the untreated digestate one. The next webinar scheduled will then illustrate in more detail the treatment process and efficiency. The struvite pilot was installed after the biogas plant of a pig livestock farm, and it treats the digested clarified liquid fraction produced by a screw press solid liquid separator. This clarified fraction is first slightly acidified to mineralize a quote of organic phosphorus in orthophosphoric mineral form, and also to reduce ammonia emissions by acidification in this pre-treatment tank acidification. This acidified digestate is after microfiltered at 40 microns with this equipment on the left side, and after loaded into the struvite reactor. This is in stainless, where magnesium and a base are added. Microfiltration, magnesium, and the base are used to promote the crystal development of struvite in the reactor. From the bottom of the reactor is discharged a precipitate with struvite, while from the upper surface exits the treated surnatant digestate, depleted in nitrogen and phosphorus. The next, Daniel, please. A monitoring activity was carried out to evaluate the nitrogen emissions from soil application of the treated and untreated digestate. The nitrous oxide emissions was monitored by a static chamber method for 1 month after the spreading phase, while the ammonia emissions was monitored by wind tunnel techniques for 7 days after the spreading. The nitrogen emissions has some of ammonia and nitrous oxide from land application of the output treated matrix were 19% lower than clarified input digestate, because the treated surnatant was depleted in nitrogen content and the thickened fraction was slightly acidified. Next, and the last. After the struvite treatment, the surnatant fraction was depleted in phosphorus and nitrogen compared to the input clarified digestate. Technology for nutrients recovery from slurry and digestate also allow to reduce emissions derived from digestate soil application in air and in the soil, because the processed digestate is more stable and characterized by a less ammonia nitrogen content. And also the precipitate containing struvite should be exploited by a fertilizers producer, and it should be used as raw material for the production of phosphate fertilizers. But this point will be investigated better in the next webinar. I conclude and I leave to Paolo for the next speaker.
Thank you, Giuseppe. My name is Paolo Mantovi, and I've been, I can say, a pure researcher at CRPA for around 25 years. And since 2022, I've been the director of the center. And I was the responsible of this operational group, SOS Acque, where we carried out trials at CAT Cooperative in Correggio in the province of Reggio Emilia and at Leona Farm in Codigoro in the province of Ferrara. This is the scheme of the complete trial that we made in both the biogas farms, starting from the classical solid-liquid separation of digestate, followed by the innovative treatment of microfiltration at 50 micrometers. And then the microfiltered digestate was utilized for the fertigation of crops for silage to be used to feed livestock or to feed the biogas plants. Next, Daniel, please. The keystone of this treatment scheme is this microfilter that is capable to separate particles that are larger than 50 micrometers. And to give you an idea, 50 micrometers is the dimension of around 3 white blood cells. This is now a commercial equipment that is applicable to full scale, is manufactured by VAM Group, and the flow rate can reach 10 cubic meter per hour of microfiltered digestate produced. The cost of this equipment can vary between 30 to 40, around 40,000 euros. Next, please. So at Leona Farm, we fertigate using the microfiltered digestate mixed with irrigation water by means of a sprinkler irrigation. You can see in the photo the Ranger sprinkler system and a particular of the system that we designed and we apply to inject the microfiltered digestate in the flux of the irrigation water. We used around 1 part of microfiltered digestate for every 10 parts of water. And in 2 applications, we satisfied the nitrogen need of the maize. Next, please. While at CAT Cooperative, we have worked both on maize and sorghum by means of a subsurface drip line system, where the drip lines were placed in the soil at a depth of around 30 centimeters and at a distance of 1 meter from one drip line and the next one. Here we used 1 part of microfiltered digestate for every 20-30 parts of water during 5 to 10 applications, depending on the crops and on the climate of the year. Also, in this case, we designed a system to inject the digestate into the drip line system. What is important is that the drippers of these drip lines have a dimension, a minimal dimension of more than 100 micrometers. So when we microfilter with a screen that has 40 or 50 micrometer space, we exclude all the particles that can create problems for drip lines and also for the sprinkler of the Ranger system that we have seen before. Next, please. So with this application systems, we fulfilled the 4R principles for nutrient application at field. Right source, because the digestate was obtained mainly from livestock manure and plant materials, residues. Right rate, because it is possible to match the amount of nutrients the crop needs. Of course, digestate analysis are required. Right time, because the digestate is supplied when plants are growing and need nutrients. And right place, because the nutrients are carried with water where the crops can use them. In fact, this solution is placed close to the roots. Next, please. We measured both ammonia emissions that were reduced to we call ultra low levels because the ammonia emissions in the drip line system were reduced at a percentage of less than 1% of the applied nitrogen. And we measured also soil nitrate concentration in soil. And we verified that in the SDI system, there were no peaks of nitrate in the soil, and on the contrary, where in the business as usual thesis, we had some important peaks in nitrate concentration. Next one, that is the last. Conclusion, complete pilot plans were developed and validated at farm scale, and compared with the normal practices of slurry digestate use, the microfiltered digestate to fertigation can strongly reduce ammonia emission and minimize nitrate leaching and runoff, increase nutrient use efficiency of the digestate slurry because we use the nutrients when the crops are growing, and make it possible to replace completely or almost the mineral fertilizers. Of course, logistical aspects must be considered in detail because the microfiltered fertilizer is still largely composed of water as the raw digestate from which it is obtained. So logistical aspects are very important in defining the sustainability from the economical point of view of this application system. Thank you very much.
Thank you, Paolo. We have a question from the audience directly for you. And the question is, what happens to both the solid and the dense fractions?
Yes, in the scheme, we have seen that we obtained a solid fraction and a dense fraction. The solid fraction is normally very appreciated from the farms that ask for this fraction because it's easy to manage and it's easy to apply. And the nutrient concentration is higher than in the other fractions. The dense fraction has characteristics that are very similar to the raw digestate. The dense fraction can be stored and used as the raw digestate, normally before the plugging of soil incorporated in the soil, or the dense fraction can be retreated in the solid liquid separation and the microfiltration to increase as much as possible the quantity of microfiltered digestate we can obtain.
Thanks, Paolo. And with that, I think, Stephen, feel free to take control of the slides.
That's lovely. Thank you, Daniel. So my name is Stephen Meredith, and I'm with the Irish Organic Association, a organic certification and development organization based in Ireland. And I'm going to speak briefly about the Maximising Organic Production Systems project, or MOPS. It was an EIP initiated by the Irish Organic Association running from 2018 to 2021. And it was examining how to improve the sustainability performance of organic growers. And essentially a big part was to improve the continuity of supply, increase the supply of organic horticulture into short supply chains within the domestic market. It took a multi-actor approach, range of different stakeholders across 11 farms, including a lead agronomist, farm advisors that were regularly monitoring the farms, and other practitioners. So you can see there on the map, you had you had 11 organic farms participating across the country, and they were ranging in different sizes from about 1 hectare to 100 hectares. So some also were straight crops, and some was a mix of crops and livestock, all with different experiences of routes to market, from direct selling to selling directly into supermarkets and food service. And a key element of the project was working with these growers to develop and optimize their cropping programs so that they could meet better the quality requirements and support better continuity of supply by not only improving their on-farm management, but also working better together. So alongside these cropping programs, really a very important element was to improve their soil and nutrient management practices through regular exchange between the lead agronomist and the grower themselves. And overall, these practices are really important in terms of optimizing their production methods, and the principles are transferable to different organic crop management contexts. So I'm just going to touch on some of the elements from a soil and nutrient management perspective that we looked at in the context of the project. So firstly, we focused on green manure trials. So as many of you may know, short and long-term green manures are regularly used in organic farming to build soil fertility through nitrogen fixation, as well as supporting wider soil and nutrient management, acting as a cover crop to protect the soil, as well as a catch crop to take the runoff of nutrients. In this project, we were looking at different mixes of short-term green manure trials, which hadn't been looked at in an Irish organic horticulture context before. And we were looking at this specifically in one farm in the southeast of the country over 3 years. So the trials included different green manures, both for summer and winter, with controlled plots, followed by cash crops of white cabbage and onions after the summer green manures, and broccoli and red oak leaf lettuce after the winter green manures. These were sown or transplants 3 weeks after incorporation. So you had 3 years, 3 different types of green manures, 2 seasons, 2 different crops, cash crops per season. So what we found was over the 3 years was that the short-term green manure trials in the main showed very beneficial effects for each of the successive cash crops, including higher soil nutrient concentrations, more beneficial insects, greater functional soil diversity, greater soil organic matter, better weed control overall. And generally across the 4 cash crops, there was accelerated development. So this was allowing not only to improve development, but also allowing the farmers potentially to extend the growing season. And despite differences in weather over the 3 years, we did see consistent improvements across those 3 years. You can see there on the slide, we have an example of the winter green manure trials, just looking at some of the positive benefits for the broccoli and red oak cash crops. I suppose it's also to point out that we did also find in one of the trials that there was that the rye and vetch wasn't necessarily as it was beneficial for the soil, but it did have an inhibitory effect on the lettuce in that you weren't getting the weights that would have been desired. And this may also be due to the fact that when you have high concentrations of field rye in a green manure trial, it can have an inhibitory effect on certain crops. But overall, generally, we found that the short-term green manure trials were very positive, both from a soil management point of view, but also from a crop development and yield perspective. So another element of the project we were looking at was trying to examine the best use of organic materials. So obviously in an organic farming context, organic manures and other materials are a really important part of improving nutrient availability and also building the soil organic matter within organic crop rotations. So in the project, each farmer was working directly with the agronomist sort of to assess their own soil and nutrient management, looking at soil sampling, but also the plant analysis of the crops and taking into account soil type, nutrient status, previous cropping rotation, looking at the crop tissue of different plants, historical manure application, and then sort of really trying to understand the crop nutrient requirements of different crops. And this was a very much a bespoke assessment, because different farms have different organic materials available to them. So you can see, for example, some of the examples of manures that would be used in organic farming. So on the larger farms that had a mix of livestock, they would have quite good access to farmyard manure that could be composted. In other contexts, they had to buy in compost. So it was really, I suppose, a knowledge exchange approach, creating the space for growers and agronomists really to explore existing soil nutrient management practices and therefore improve their overall crop performance. So they were sort of the two sort of key areas that we were looking at from a soil and nutrient management perspective. I suppose just maybe to recap, I've touched already briefly on the organic manure trials in terms of their beneficial agronomic effects. The sort of, I suppose, drilling into how different farms were using the organic materials was allowed the farms to improve that. In some cases, farms were maybe using they were applying too much organic manure to their fields, where they were able to sort of streamline that a bit better to improve that over time. But also a really important part of the project was in terms of the business development. So a key part of the project was really about facilitating improved market development and improving the continuity of supply. So what we did find over the 4-year period, that there was a significant increase in sales turnover from 3.8 million in 2017 to 8.1 million in 2020. So not only was the improvements of practices at farm level, but also the cooperation amongst the farmers was really important. And what you can see there on the graph is that it allowed the farmers to improve trade amongst themselves, to improve the, I suppose, the range of products that they could make available to consumers, but also it allowed intertrade between other growers that were outside the project. So it just sort of showed the importance of grower collaboration for improving the continuity of supply. So finally, just to say that we've developed a number of stakeholder guidance materials, including a growers report and videos to promote some of the different growing techniques, and also to provide examples for new growers or existing growers in terms of the market prospects, different cropping plans that were used by the growers, a technical note on the use of different organic materials, as well as an overview of the results of the green manure trials. So they are all available, excuse me, they're all available on our website, or also some elements on the NUTRI-KNOW website. And I'll pass over to the next speaker. Thank you very much.
Thanks very much, Stephen. My name is John Hendrick, and let me see, I'll take control here. Move on to the next one. I'm John Hendrick, and I'm working with Teagasc, which is the Agricultural and Food Development Authority in Ireland, and that's a state agency that provides research, advisory and education in agriculture, horticulture, food and rural development in Ireland. Today I'm going to speak about the Duncannon Blue Flag Farming and Community Scheme, but I'll condense it down because I'm aware we're running a little tight on time. It was a cooperative EIP agri group based in the southeast of Ireland, and the main reason why this group was formed was this beach here on your screen. Within that black line is a catchment area which was identified as a cause for this beach losing its blue flag status in 2007 due to bacterial pollution of the waterways, and a large part that pollution of the beach, which was a bathing and shellfish fishing beach, was the waterways and the actions that the cooperative group, as in the local government, the local communities and farmers, were having on water quality. So the effects they were having on the water quality within that catchment area. With regard to the farmers themselves, there's within that catchment area 975 hectares, 35 farmers, 4 dairy farmers, 8 arable farmers, and the balance of 23 were dry livestock farmers. They all received advice and support from a sustainability manager, which drafted plans which identified in a traffic light system of red is red, amber, and green, identifying the risks for water quality being damaged from the land or the farmers and their actions. And they were offered a financial incentive to change what they're doing on their farms, which would increase the quality of the waterways. So some of these water protection improvement works that they had to implement as part of these PPZ, these pollution potential zone plans, to get that extra bit of money, which also satisfy the nitrates directive requirements that they had to do, which all farmers have to do in Ireland. So the water courses, the drinking points, they're all listed there as the different actions were taken. But just to summarize it, I'm going to refer back to what Hong Zhen said at the start, which was right source, right rate, right time, and right place. If you look at these here, the right source, the matching of fertilizer formulation to crop needs, there were soil analysis, organic manure analysis, and nutrient management plans drafted. So that by doing this, the fertilizer was being matched to the crop's needs. That's the right source, the right rate, because the amount of fertilizer that was in the ground that the crop needed and that the farmers had to place on the crops, the right rate was applied. The right time, the sustainability manager and regulations were in place to ensure that fertilizers were spread within certain windows of spreading. There was restrictions on spreading at times of year where nutrient losses would be more likely to happen. And also the right place, keeping the nutrients where crops can use them. This is a combination of things. By the use of less low emission slurry spreading, this was keeping the nutrients from escaping into the atmosphere. By the use of riparian zones and buffer zones, this was keeping nutrients away from the water courses, but it was also helping the farmers become more efficient and more profitable, because they were both saving on the input costs they were using in fertilizers, had better resource use, and they were also receiving the payments for successfully completing their plans that were drafted as part of this EIP Agri group. So I will hand you back over to Hong Zhen. Thank you.
Yeah, thank you, John. So that's the main content of this webinar, but you can also find more details in our booklet. As you can see, we have 6 booklets, and this is the main content in the application booklet you can find from our website. That's a NUTRI-KNOW website, and of course we have this section for different operation groups. You can go through more details into it. Besides, as Daniel already mentioned from the beginning, we have this community of practice that you, in different native languages, you can register, and then, based on your preference and interest, ask a question or review the knowledge shared over there. So thank you very much. We are happy to take any question from you.
Oh yeah, so we have a haste rant by Kevin. Kevin, go ahead, please. You should be able to. Yes.
Hi, my name is Kevin Kaiser. I work for Econovis in Luxembourg, and we are involved into a project called Renew to Cycle, where University of Ghent is also our partner. I have a question for the slide number 5. Is it possible to go back, because there's some let's say it in a rough way, a little bit superficial claims made but I'm interested if those infos are to be found in the booklets, or do you have a source where I could get these details, such as yeah, exactly, such as reduction of fertilizers by 20% and so on and so on. Is this info in your booklets available, or are these claims made by findings from your project?
Well, if I can, well, these targets are based on the farm to fork strategy that's announced
Okay.
at EU. So it's not really our results, but it's our goal as well in our operational groups to try to contribute to these
Okay, I
goals.
see.
Yeah.
Then I totally misunderstood because the slide went so fast. Okay, sorry.
Yeah, sorry.
And farm to fork, yes, I just Googled. It's a strategy.
Yeah.
Okay. No, that's all. Thank you.
Thank you as well.
Are there further questions by the audience? Feel free to raise your hand or type your question in the chat, whatever is easier for you at the moment. We have 4 more minutes left in the webinar. Maybe while you're thinking, a brief note. We always try to evaluate our webinars and improve the subsequent ones. So here in the link I posted, in the chat, I posted a link to a quick evaluation. Should take you roughly 1 minute, where you can answer 5 questions about how you liked the webinar and what we can improve in the future. So feel free to click on that link and yeah, and respond. We would appreciate it very much. And it seems there are no further questions popping up. So just, yeah. So I think with that, we will close the webinar for today. Thank you for everybody, yeah, for attending. Thank you to the speakers for presenting. And I hope, or we hope to see you in one of the next webinars. Until then, have a nice week. Thank you and goodbye.
Thank you. Bye-bye.
Thank you.
Thank you.
Goodbye.
Bye-bye.
Thank you all.
Thank you.